How's it going? So we have this question. What is the error when the integral is approximated by the trapezoidal rule with n equals 3? And the function we're integrating is this function here, sine of pi x. So I went ahead and graphed that onto Desmos. So that's an online graphing calculator. Hopefully you are familiar with it. If we look at the function here, we can see that it looks kind of like a parabola. So this is our function, sine of pi x. And what we can do is get the area under the curve. So we're talking about the space in here between the curve and the x-axis, right? So the area under the curve is the area between the curve and the x-axis. So we're going to try and get this area. Now we know two different ways to get this. One way to get the area is to use the trapezoidal rule, which we'll talk about in a second. The other is to use the integral. The integral is exact. So the integral sine pi x dx from 0 to 1, right? Since we're starting at x equals 0, and we're going to x equals 1, is exactly, this integral is the exact area perfectly fitting on this line. The trapezoidal rule is not exact, so it's an approximation, which means that it's going to be wrong. If you see the word approximation, it means it's going to be wrong. There's something called error in approximation. So we can say the area exactly, let's say A exact is this integral. So we can calculate this first. You could do this by hand, but I'm going to use a calculator to save some time. If you don't know how to do it by hand, let me know and we can talk about that. But in my calculator, I'm going to make sure I'm in radians because our angle is going to be in radians. And we're going to do the integral of sine of pi times x. Sorry, you can't see this. Here's the calculator. We're doing the integral of sine of pi x. We're respecting x, so we're doing this with respect to x. So we are going to put comma x in my calculator. That's how this calculator does it. And then we're going to put in our bounds. So we're going from 0 to 1. So this will tell us what the exact area is. We get 2 divided by pi. So the exact area is 2 divided by pi. That's important to know because we're going to subtract. Well, I'll tell you in a second, but this is exactly what this area is. So I'm going to erase the integral now. And I'm going to move the calculator away. So we know exactly what this area is under this curve. But now what we're going to do, and maybe the harder part, is to get this approximation. So we have to use this trapezoidal rule. And to know, in this case, what the trapezoidal rule is, we have to know what the letters are, or the things here. So it tells us, gives approximate area under the curve f of x on the interval a to b. So our a is the starting value, which in our case is 0. Our b is the ending value, in our case is 1. That's what this means here. There's like a line, you can't really see it, but there's a line, and then 0, 1, sine of pi x dx. Okay, so we're got a is 0, b is 1. And n, they tell us what n is. It's how many times we're going to divide this chunk up. So if you look over here, what we're doing is we're going to sort of approximate the area like this. And then we're going to approximate the area like this. Whoops. And then like this. So you can see, maybe you can see the shape of a trapezoid, right? If you follow the outside edges, that's why this is called the trapezoidal rule, because there's a trapezoid basically when you make it. And when you do it with more points, the trapezoids are harder to see, but here you can see it really easily. So what we need to do is just plug into this formula. And I'm not going to explain where it comes from, but I'm just going to plug in. We can talk about where it comes from later. Okay, so we can approximate the trapezoidal area, or we can get the exact area of the trapezoid. So basically what we're missing when we do this, if you look closely, is this area. Whoops. This area up here. And these little bits between the red and the blue lines there. It's missing because we're only going to calculate the area inside the blue spots with this trapezoidal rule. We're going to calculate this triangle, this rectangle, and then this triangle as well with this rule. So this is going to be approximate. So we'll say A approximate. I'll just say A app for approximate. Is going to be B minus A. So B minus A is 1. N is 3. So we're going to divide by 2 times 3. Because that's in the trapezoidal rule. You do 2 times n. So really this is 1/6 times all this stuff. So our f of a is f of 0, which if we look at our spot on the graph, it's 0. So f of a is 0, plus 2 times f of x1. f of x1. Where is x1? x1 you get by adding b minus a over n. So we're going to get x1 is equal to the starting point, which is 0, plus b minus a, but b minus a is just 1, over n, 3, so 1/3 times 1. And then x2 is x1 plus that same thing, 1/3 times 1. So really what this means is x1 is 1/3, and x2 is 2/3. And then x3 is the same thing as b, which is 1, because that's 3/3, right? So basically what we're doing is we're taking a 1/3 step, a 1/3 step, and a 1/3 step. Why are we taking 1/3 steps? Because the distance we have to cover is 1, right? We have to go 1, and we want to take 3 steps. That's what n equals 3 means. So if you're going to go 3 steps starting at 0 to 1, you have to take steps that are in the size of 1/3. And that's what your x1, x2, etc., until you get to f of b. So 2 times, in this case, it's just f of 1/3. So it's f of 1/3. Because that's the height. Look here, this is the height. What we want to do is basically what we're doing is we're calculating this area of this triangle by using this formula. So we're going to put in here, 1/3 is 0.33, but f of 1/3 is 0.866. So in our case, this is 0.866. I already calculated this earlier and put it on the graph. If you see, this point is exactly where we're going to. And then we're going to do plus 2x f of x2, which is 2f of 2/3, which if you look at the graph at 2/3, which is 0.667, again, the height is 0.866, so it's actually the same height, which is interesting. Okay, and then f of b, right, we're just going to add f of b at the end here, so f of 1. But actually, if you look, we're back at 0, so this is 0. So really what we're just going to do is we can cross out the 0 parts and just add this stuff up and multiply by 1/6. So now we're going to bring out the calculator again. And what we get, if I type this into my calculator, is going to be 1/6 times 2 times 0.8666. We'll just add a couple more sixes on there, plus 2 times 0.866. Assuming it repeats. So we get 0.577 etc. So here we get this number 0.577. So if we look at that number, that's the approximate area given the rule that we just used. So we can say A approximate. And the 7's just repeat. So now the question is, well, what's the error? The error is going to be the difference, right? So we have, if we take away the calculator, we have the exact area and the approximate area, but the error is the difference between them. So I'll write this: error E is equal to the exact area. I'll just do EX minus the area approximate. And if we do that, we have to do 2 over pi, because that was what we got for exact area, minus 0.577. And we'll just put a couple extras on there just to make sure we get close enough digits. So if we look, we have to type into our calculator this 2 over pi. Let's see what that is by itself as a decimal. If I get my calculator to tell me what the decimal is, it's 0.6362, this number. So this is a little bit bigger. And when we subtract 0.5777777, we get let's move the calculator. Whoops. So we're doing this error calculation. The calculator told us this number is 0.58843. So we'll just say 0.588, and if we round that, sorry, 0.0, 0.0. So there's a 0 after the decimal that I missed the first time I wrote this. So it's 0.0588, which if we round that to the 3 digits, which is what these answers have, 3 digits, 3 decimal places, 0.059 is the error. And if we look, that's answer choice D. So this is how we get the error. We do the exact area, which is using the integral, and get the approximate using the trapezoidal sum. Any sum is going to be approximate. It's not going to be exact, which means there's an error between what it actually is and what's there. So this green thing is the missing part, is another way to think about it. This area, all of these little squiggles that I drew earlier, is the missing part from the sum formula. That is, you get it for free. You get it exactly when you use the integral. So the integral is better in that way. It gives you the right number, right? But it's harder to know the rules for that, to do it by hand. So we just used our calculator when we did it, but we found the trapezoidal rule by hand. Okay, that's all I'm going to say there.